webinar in this month, and we are pretty excited because we have successfully completed 18 webinars and we have only 2 more to go in this month. Today's webinar is by Markus, and he'll be delivering the webinar on from SQL to R, how to leverage your T-SQL knowledge to learn R. So it'll be pretty interesting. Before we start the webinar, a quick word about the Data Platform Geeks community. It's a subsidiary of eDomino Systems, who also have companies like SQL Maestros and Peopleware India, who specialize in training across India and also online trainings. Please go ahead and explore these links. There are much more to learn from these companies, as well as follow Data Platform Geeks. If you are attending the webinar today, you would have already known about Data Platform Summit. This is the 4th year of the conference. We are running this conference in August every year, and this year it's from 9th to 11th of August, the 3 days conference. And before that, we have 2 days of full day trainings. This is happening in Hotel Radisson Blu, formerly Hotel Park Plaza, which is in Bangalore. The conference is 3 days, purely on data analytics and open source. The 2-day pre-con trainings are full-day trainings. There are 12 full-day pre-cons. We have 7 tracks and speakers from all around the world, industry experts, Microsoft certified masters, Microsoft most valued professionals, industry stalwarts are coming and speaking at this conference. They'll be also networking with the attendees, so this will be a wonderful chance to meet them and learn from them. It's a 100% learning event. There's no marketing at this conference. Please do visit dps10.com to know more about the conference. Let me quickly introduce you to the team behind Data Platform Geeks. Amit Bansal is the founder and president. Manohar Puna is the vice president. I'm Manohar Puna. I'm the vice president of this group right now. Avnish Panchal, Prince Rastogi, Sandeep Pani, Yogeshwar Pul, and Surbhi Agarwal are the core pillars behind this community who help in building the community and taking this community forward. eDomino Systems, they are the backbone who help us organize these events and run everything smoothly. And a special thanks to Microsoft, who have been a great support and help us running this community. If you are attending this webinar today, you would have already registered on dataplatformgeeks.com. If not, please do so. If you have registered recently and did got a chance to explore it, please go ahead and explore it, because there are a lot of free content available. Everything on this site is free, the free videos, the labs, magazines, and there's a lot of information in terms of blogs and other videos. This is one of the largest data communities in the world and one of the largest SQL groups on Facebook. Please do join the groups, Facebook and LinkedIn, and post your questions. And if you are interested, please go ahead and answer some questions. This will help everyone learn and continue to grow the community. With that, I'll quickly hand over to the speaker, Markus, today. Markus, it's up to you. Thank you.
Yeah, hi everybody. I will share my screen in a second. Desktop, share screen. So you should be able to see my screen now. Is this true?
Yes.
Wonderful. Yeah, good morning, good afternoon, good evening. Welcome to my talk from SQL to R. Leverage your knowledge in T-SQL to learn R. So where can I click? I have to change to my, where's the slide? Here are the slides. Now, so my name is Markus Ehrenmueller Jensen. As you can hear, I'm not from India, I'm from Austria. Currently in Denmark, visiting friends over the Easter weekend. You can see all my contacts here, by the way, all the slides and the demos are already uploaded to the link the organizers provided to me. So after the talk, you should receive an email with a link where you can download all the stuff. I'm into the industry since many years, working with SQL Server since version 2005. Certified on all of the data platform tracks. Can I go get the chat away here? I'm the organizer and the leader for the past chapter in Austria, which is like the Data Platform Geeks in Austria. We do also a SQL Saturday once a year in Vienna, which is the capital of Austria. So if you want to come to Austria, please join us. Would be wonderful to see you around. I'm also the author of one little ebook about Microsoft Business Intelligence end user tools, and two courses out in Pluralsight, also about BI tools. And I'm really pretty proud that I was awarded with as a Microsoft Most Valuable Professional at the beginning of 2017. So today's talk is about R. So we will have an introduction to R. This is really basic level. If you never heard about R, that's the talk for you. And then we will take a look how R as a language and as a service and as tools are integrated into the Microsoft Data Platform. We'll take a closer look to how it is integrated to the SQL Server database engine, to Power BI, and to Azure Machine Learning. So what is R? R is a programming language. It is strong and dynamically typed, as we will see in the first demo. It is a functional language, and it is interpreted, so there's no compiling involved. It is open source and has lots of packages. So packages are like libraries where you have functionalities and sample data where you can do cool stuff, like there are lots of packages for statistical functionality. So if you're into metrics calculations or do descriptive statistics, there are packages out for you. If you're into machine learning, like linear regression, clustering, neural networks, there are tons of packages out there in R, and also really cool data visualization packages where you can plot the data, to visualize the data, to discover things in the data. So SQL and R have a lot of things in common. So both languages are used by data people. So I guess you work with data in your daily life and probably work with SQL and T-SQL currently. So R should be really interesting for you. Both languages provide tools like file, it's clean, it's stirred, and both in control of over 11,000 packages. But the aim of this talk is to get you started with some of the packages. And that's where we go to the demo, and we will take almost all of the time in the demo, so you can you get a feeling about how R is working, and how R feels like a language. So what I've opened here is the R Studio. R Studio is an open source IDE, integrated development environment. You could also use Visual Studio, which will then mimic, if you open the R package, which will then mimic the lookalike of this screen. So on the left upper corner, I have opened an R script. So I prepared a script, so I do not have to type everything, but just can execute it to make my demo more succeed. And then we have the console down there. So if I mark something here like 1 + 2, and I can execute this, then it just copy it down to here, and then it's executed. And I could also type something like 3 + 3 and execute it. So this is given 6, which is probably not a surprise for us. On the left hand, we have environment, like I can see what variables or data frames, so we'll hear about data frames in a minute, are available, already loaded into my environment. And at the lower corner, I've got the files and plots and stuff like that. So we'll basically stick to the left side, and I will execute some stuff here, and I will explain what I'm doing here. So the most important stuff in the language is how to comment, because comments are the only documentation, if you ask me. In my opinion, it's the only documentation which is really up to date, because if you see a script and you see that the comment is not true, you most likely will correct this and make it better. But if there's a documentation out there in a Word document or on a SharePoint site, most probably, there's a high probability, high chance that nobody takes care about the documentation. It is then outdated easily. So comments are really easy to do. You just start a line with #, or you put the # after your R code, and the rest of the line is then a comment. So that's not executed. If I mark the no multi-line comments are available, and nothing is executed, because you see, it's just a comment. We can then, do calculations, as R is coming out of statistics and mathematicians, and that's also the reason why there's a lot of packages, because many academics using R, many academic statisticians and mathematicians using this, and when they discover a cool thing, they write the packages and their examples for R. So if there's a new cool thing in statistics, data scientists, or visualization, then there's a high chance that there's already a package out there in R, because academics are really using it. So we can do different calculations. We can also work with assignments. So we can declare variables. And as this is open source, there's not just one way of doing assignments to a variable, but several ways. So if you're into R, then you are into T-SQL, then you would, can recognize this. So that's assignment. So the variable A is assigned the value SQL to R, and if execute this line, that's just executed, no output is done, and we can see that there's a variable A SQL to R available here. We can also do the left assignment. So this is not a greater minus, but it's like an arrow. So we're assigning the value from the right to the variable on the left. So that's the left assignment, which is doing the very same like the equal sign. We also have the right assignment. So we can assign a value on the left. Sorry, we can assign a value on the left to a variable on the right, which will do just exactly the same thing. And there's the assign function. So we can assign a value via a function. R is function based, so there's no surprise that there's also a function available for that. I have to assign to the variable A, I assign the value is equal to R. So that's doing the very same like all the others, and we can see the value of a variable not only in the environments but also in the console, but just executing the variable name, and then it's executed. Then we can see SQL to R is the content of this. We can also execute the assignment and put it in parentheses. Then the execution is done, and the output or whatever the execution has done, the assignment has done, is then shown to the console. So so the value is assigned and then also shown to us. Be really careful, because the assign, sometimes we have to put things under quotes, and sometimes we don't have to. And if I use the assignment function with quotes, we could see that then the value is assigned to the variable with the name A. If I put a variable A without any quotes, then the assignment is not done to the variable A, but it is done to a variable which is named like the current content of A. So if we execute this, we can see that another content, and if we execute A is still SQL to R, like we did the assignment previously. It's not assigned to another content, but now we have a different variable, because the current content of A is SQL to R, and as we executed this without the quotes, so now we got a new variable SQL, which is named SQL to R, which is the current content of A, and to this variable we the value another content is assigned. So that can be a little bit confusing, because it's nothing we have in T-SQL. Then I mentioned that R is dynamically typed. So we can assign a value 1, which is an integer, to the variable A, and execute this. We can also then reuse the variable A and assign a I'm just liking the English word. This is an array, like an array. So we can combine values 1 and 2 to an array, and A is then not an integer, but an array of integers. So that's also possible. So that does mean that it's dynamical. So we can reuse variable names and assign them values from different types of values. But it's also strong type. So if I have a variable A, assign it again the integer 1. Then we have a variable B, assign X, Y, Z to it. So that's a string, that's not an integer. And when we then try to add A plus B, 1, the integer 1, and the string X, Y, Z, of course, this is not possible. And we end up with an error like here in A plus B, non-numeric argument to binary operator. So non-numeric, the X, Y, Z is non-numeric, so we cannot add this or use it in addition. but a strong dynamically typed. So when we then assign the value 2 to b, of course, we then can execute a plus b, and 1 plus 2, like a plus b, executes as 3, as should be no surprise to us. R is also case sensitive, so I'm not sure how you're using your T-SQL and SQL Server databases. I'm not a big fan of using case sensitivity in my databases because it's always confusing me, but there's discussion out there. What's better or not? R is, as a matter of fact, case sensitive. So if we have a variable a in lowercase and then we have another variable with a in uppercase, that's a different thing. So we can have, like we can see here, a now has equal to r in lowercases, and a as a variable at lowercase still has another value. So that's two different things, as we can also see in the console if I execute this. So we have a variable called a in capital and a variable a in lowercase. Then we have lots of functions. So of course, there's also a function to quit the console. I will not execute this now in the demo, but there's lots of functions out there in R, as it is a functional language. So we can have help, which is mandatory for all the functions and packages. So I mentioned that R is, and the packages are open source, but there are some standards which have to be applied. And one is that all the packages have to provide the help function, the documentation with which explains all the parameters of the package and the functions in the package, and also examples. So we'll not execute the rest of this, and I will show just a small amount of descriptive statistics. So we can again have an array with the values 1, 2, 3, 4, 5, combine those values to an array, and then execute or calculate the mean of this. So the mean of those values would be 2.75, the median would be 2.5, and the standard deviation would be 1.7 and something. So that's easy, an easy introduction into what R can do. We can then go a step further, and I want to discuss at least some of the data types. So I will parse a little bit quicker through this demo, so we have some time for Q&A at the end. And as I said, all those scripts I show you are already uploaded, and you can play around with them after my talk. So basically, we have numeric data types. We already have the scene. So A is a numeric data type, and with the mode function, we get the result numeric, as this is a numeric value. There are also characters we can use, as you can see here. Double quotes and single quotes doesn't really matter. We also have a logical data type, and we have complex data types. It's a long time ago that I had to work with complex data types. I'm not sure how much you are currently into complex data types, but you can do calculations with complex data types in R. Then there are special values, like if you execute a calculation like 3 divided by 0 in T-SQL, you would get null, because the that would be infinite, and there is no infinity in SQL, but yeah, then the null is just used for this. Usually null is unknown, but it's also used for calculations which did not work really out. But in R, we have different kind of nulls for these cases. So we get the mathematically correct answer for that. So 3 divided by 0 is infinite. And if I execute this, we can see inf here. We can also use inf as a constant, and we can check if something is infinite or not. So inf is infinite 4. This returns a logical false, as this is not infinite. Infinite of 3 divided by 0, of course, is true, because this is infinite. And there is also negative infinity, so minus inf. So if I divide minus 3 by 0, then I get minus infinity. We'll skip some of this. Then there's another thing which is not a number. If you divide 0 by 0, that's just not a number. And that's what we get here. So NaN means not a number. And again, we can check if something is not a number or is a number. So 4, of course, is a number. So if we execute this, is NaN 4, then we get false. Is NaN 0 divided by 0, then we get true. And there's a third thing, which is not available. So yeah, there could be some calculations which are now, sorry, NA, that's the classical use case for null. So if we have in a database, we just don't know the address of a person or the birth date, then in a classic relational database, that would be null because it's more or less unknown. And this is transferred to not available in R. So if you load some data from a relational table into R and there is null in the relational database, this will end up as an NA not available in R. And then you can also check if something is infinite or is not a number, equals not a number. This is just not available. Don't ask me about the mathematics behind that. I'm not really into those things here. Yeah, then we have metadata about objects. So again, we can have an array of values, 1, 2, 3. That's a numeric, and the class is also numeric. We could also have matrices, so we can build up a matrix of one array. It's a vector, so I can remember. So this combines values not to an array. Sorry for that. This combines values to a vector, as it just came into mind for me. And there's also a list of values. So the difference between a matrix and the list is in the matrix, all the data types of all those arrays within the matrix, all those vectors within the matrix have to have the same data type. And a list can consist of different data types. So there could be a matrix in it, there could be a vector in it, there could be in the very same list also a string or something like that. So that's like a record in .NET or something like that. And the most important stuff is the data frame. So a data frame, again, consists of rows and columns. It's like a matrix, but it's more closer to a table. If you ask people who are into R, they will explain you that a data frame is not a table. If you ask me, I would say a data frame is the closest thing we have in R to a table. And as we will see during the course of this demo, a data frame really behaves like a table. So I'm almost sure that the data frame is a table. And that's what we will make most if we load data from, for example, SQL Server to R, then we will always load it into a data frame, and then we can work with the data, as you will see in the upcoming demo or the demo in a minute. That it really behaves like a table. We can do things we would also be able to do with tables in SQL. So this data frame has a mode of a list. The class is data frame, and str stands for structure. So we can see that this data frame, it's a data frame. It's called data frame, and it has 3 observations of 1 variable, and this translates to 3 rows which with 1 column. So the variables in a data frame are like the columns in a table, and the observations are like the rows in a table. So let's get closer to the data frames, because I think this is a really important concept in R, and that's the thing we would work in R when we load tables into R. So I build up 3 vectors. So I have a vector called call1, call2, call3, and I can mark them and just execute them. And then there is this function called data.frame, with which I can convert the through vectors, call1, call2, call3, into a data frame, which I really creatively called df as a data frame. So if you show that, we can see we have 4 observations, so 4 rows in the data frame, 4 observations, as you can see here, 4 observations, 3 variables, and we can click on it, and then it shows up like a table, and we can see the very same here in the console. So there is 3 columns, call1, call2, call3, which are called variables, and you have 1, 2, 3, 4 observations, which would translate to rows in a relational table. And we can then select just 1 cell out of the data frame. So 3, 2 means that we get the 3rd observation and the 2nd variable. So 32 is like, as we can see here, from the 3rd row, the 3rd observation from the 2nd variable, 32. We can also select a whole row, a whole observation, by omitting the column in the square brackets. So we get the whole 3rd row, 3, it's a 3rd row with all the 3 columns or observations there. The same is true to selecting a whole column. So we can omit the row parameter and then select the whole column. Don't get confused, because in this way it shows like it would be a row, but that's just how the way RStudio in the console shows us this. But it's still one column of the so 12, 22, 32, 12, 22, 32, 42 is the second column out of my data frame. We can do the same by using the names. So df $call2 selects the second column, or the column named, or the variable named call2 from the data frame df. So as you've seen here in the call to the functionality, a dot is not a special character in R. We can just use dot in names of variables and functions. And to select a column out of a table, better saying a variable out of a data frame, you would use the dollar sign. So then we get the very same thing. If the name of the data frame is really long, or you have a lot of access to just one of the columns, you can also attach the data frame. Then you can just omit the name of the data frame, and when you then select call2, it will first look up if in the data frame df there is a column or a variable called call2, and then will show this column, and we can detach it again. Or we can do the same, as I already told you. There are several ways, and as it's open source, and I'm sure I'm not able to show you all the ways. I'm sure there is some way I'm not aware of where you could do similar things I'm showing you. So there's plenty of possibilities. Just find your way. So with the with function, we can also execute or have an expression here, and this expression will be first looked up if there's a variable name, if this variable is part of the data frame called df, and then it will be used from there. If it's not available in this data frame, then it would refer to the common variables out of the data frame. We can manipulate our data frame. So I come up with the fourth vector, where I combine, C is the combine function, where I combine the values 92, 98, 97, 96, and then cbind, column bind this column to the existing data frame df. So if I show you the data frame, now we have fourth column with the values 92, 98, 97, 96. We can also by using the rbind function. In this case, I did not come up with a column fourth, but used the possibility to have call to functions as part of. So we can do it. You can call a function, and you, as a parameter, you pass in another function. That's also possible. And so we add another row by row binding a vector to our data frame. So we get the fifth row, 51, 52, 53, 54. But usually we do not create data frames by row binding or column binding the data, but by referring to data we already have out there. So one usual thing is that we load data from a CSV file. So that's the most used function, I would say, by data scientists. They will ask people, can you give me this as a CSV file? And then they will load it into R. That's what I will show you here. So I set my working directory, WD is setting the work directory to my Dropbox, where I've got all the demo data here. And then we can use the function read.csv to read a CSV file into a data frame. So the data frame factories or sales will be created from the content of this CSV file. Personally, I think it's not the best option. I mean, it's good to have this functionality available to read CSV file, but usually I work with data warehouses. So I have lots of data in the data warehouse, and it's like very inefficient if I would export all the data the data scientist would need to a CSV file, transfer the file through email, the network, a SharePoint list, or whatever to the data scientist, and he or she will then load the data. So probably it's better to have direct access to the data, and that's also possible. One of the libraries I will show you here is the library RUDPC. So that's a library for R, which enables you to connect via an ODBC connection to a database. And I have here a connection. One possibility would be to use ODBC connect. I connect to the AdventureWorks DW 2014, and as this is a local database, I'm okay with that. You can see that there's a user ID read only available with a very secret password called password. So I can connect to my local, in this case it's a local ODBC connection to my local instance of SQL Server, and then I can use the SQL query function part of the ODBC package, reusing my connection, and then stating SQL statements. So this can be easy statements like select star from DBO, dim product category, out of my venture works. This can be more complex, like having order date and sum of sales amount, and then we have a group by at the end of the statement. So this is just copy to the database you're connected to. In my case, it's SQL Server. It could be Oracle, it could be Teradata, DB2, MySQL. I think it could be also Access if you want to name this as a database. Yeah, and then we can load data directly from the database. So we're loading this data, so that means that now the data it's not a live connection to the database, but we now have a data frame called, for example, factory reseller sales, which now has all the data from the query in it, and now we can close the connection because, yeah, that's not a live connection. We're just loading the data into the memory of my laptop, so we are able to work with that. Yeah, then I'm all overthinking. Yeah, data frame is like a table, but can I do the same stuff like I'm able to do with tables? And that's what we'll see in this part of the demo. So with the head function, we can simulate what the top is from SQL. So it will show us all of the variables, all of the columns of the data frame factory reseller sales by date subcategory. By default, only the first 6 rows. So as you can see here, 1, 2, 3, 4, 5, 6. So that's not part of the data frame, but I can see that it's the first 6 rows. And as the screen resolution is the best for you to see all the stuff, but not for me to have all the data just side by side. We can scroll here to see all the other columns available in this data frame row, and by tail we got only the last row. As we can see here, 441. Obviously we have 441 rows in this data frame, or we could also say for 441 observations, like we should be able to see sales, and we can see here 441 observations. We can also do projections, so we don't get. I can again come up with a vector, combine strings to. So in this case, I only get the order date and the English product subcategory names, but nothing else. And the sales amount. So we get now all of the rows, but only 3 columns, only 3 variables: the date, the name, and the sales amount. For more sophisticated functionalities, we can use one of those plenty column packages. One is the dplyr package, so I can load the package and then we can do a select. So that's a very common thing. If you're into SQL, we select order date, English product subcategory, and the sales amount, and we're passing into the select function. That's like we're passing in. So we take the data frame like a pipes, the pipe symbol in the pipe sign in Linux or Unix if you're used to that. So we're passing in the data frame into the select function, and then it will filter down to just those 3 observations, and we get this very same output, all the rows for only 3 of the columns. We can do ordering by passing in the order function as the first parameter to the brackets. So then the rows will be ordered, and I pass in, I want the thing be ordered by the sales amount. So we get again all the rows, but they're not ordered by the row number, but by the sales amount, which is one. It's not this column, but another column. I think it's this column we're seeing here. Yeah, here's the sales amount. So it's starting with the lowest one, and then it's getting bigger and bigger. We can do the very same with the dplyr package. So we can select, and then unfortunately, that's not the order function, but it's arrange. The name of the function is arrange, and we can simulate this very same thing with the dplyr function. To filter, so where is the filter function in SQL? I guess you're familiar with, and then we can use again in the brackets, we can do the double equal sign, so there's a comparison road bikes, or we can write the in function percentage in percentage. So the percentages are necessary to let R discover that this is not just a variable name or the function name, but it's a keyword to search. So all the product category subcategory names are filtered now by road bikes and mountain bikes, and that's it. So we can execute this. Now we get not the full list, but only mountain bikes and road bikes. The same can be done, as I told you, by several ways. Another way would be the subset function, where we can also pass in a data frame and then pass in a filter function or filter condition, so we get only the subset. And in with dplyr, it's called filter. It's not called where, but it's called filter. Select, arrange, where is like select, order by, and where in SQL. To get distinct values, we can use the unique function. So then not all the categories are shown, but only the distinct values in it. And aggregating, like this is something we would do with a group by in SQL. So we would have some columns or one column, then we would have aggregate functions like a sum or an average or something like that, and we have to group by all the columns which are not which don't have any aggregate functions on them. So I come up with a data frame, so it's easy to see what I'm doing here. So I create a new data frame. The first column or variable in the data frame is called A. Then it consists of some a vector of some values. Then we have B. We make a data frame out of that, and we can see this. So we have A as 1, 1, 2, 3, 3, and B as 2, 3, 3, 5, 6. And with the help of the dplyr function, we can do a group by A. So then it's grouped by A. So we have two values A. So at the end, we only will see one row in A with the number 1. And the function we will apply is the summarize function. Summarize function will aggregate, and it will aggregate the column B by summarizing it. So then the output would be that we only get in the column A, we'll only get 1 once. And then we'll summarize the B column. So 2 plus 3 would be 5. That is what the output should be of this data frame. And we can see it as 1 and 5. This is a functionality which shows us that this is a double. So obviously R did convert those values from an integer to a double value. You can also use total, calculate total and percentages. So what I get here is that I use again the summarize function. I sum up the sales amount, and I want to have also a sales amount total, which sums up the effect reseller sales by so the name of the data frame and sales amount. So that means that the first sum will summarize everything per grouped variable, and the total will sum it up for the whole data frame. And then we can calculate also a percentage, where we calculate the sum of the sales amount divided by the sum of the effect reseller sales, blah, 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 data frame name, $sales amount. And when we execute this, we get a thing which would need us to use window functions in SQL. So we get one row per English product category name, accessories, bikes, clothing, components, and then we will see the sales amount, the total sales amount, and the percentage calculated. So obviously, over 60% of all the sales are coming in by sales of bikes. We can also calculate columns or add calculated columns to the data frame. That's done by the function called mutate. So we get another column into the data frame, or not really into the data frame, but by doing the output. So the data frame is passed into the mutate function, and the mutate function will add another column called margin, and the margin is sales amount minus total product cost. So at the very end, so we get this the margin at the very end of the data frame, as we can see here. So this margin is just added by the mutate function. And we can also do joins. So I create another simple data frame, so it's easier to explain what the joins or how the joins are working. So I create the data frame as a custom ID 1, 1, 2, 3, 3, a sales amount 20, 30, 30, 50, 60, and just create this, and then we can see that we have customer ID and the sales amount, and then I create another data frame which called data frame 2, and it also has a custom ID, but it's lacking the custom ID 3, but there's another one 4, which is not available for the sales amount with names X, Y, Z. And then we can play around with joins. So joins are done by merging the data frames. So I pass in the first data frame. I want to pass in this data frame 1. The second one is data frame 2. And then I state that I want to join or merge them by customer ID. So this is like an outer join. So all the rows are showing up. And the sales amount is empty for customer ID 4 because we don't have any sales amount. And the name for customer ID 3 is not available as we don't have any name for that because it's not part of the second data frame. The left out join is done by not all, but all X are true. So I want to have every row from the first data frame from the X data frame. But that's easy to do. So we got all the rows. We don't get the row for the fourth customer ID, and the right outer join would be the same the other way. So all dot Y is true. So we get all the rows from missing the sales amount for the fourth, and we don't see the third customer ID. And we can do a cross join. So every row from every table is combined with every row from the other table. That's that's just doable, but I don't think there are many use cases out there. So before I run out of time, I will do a short introduction into R is to make my colleagues happy by providing them not only with planned values or budget values, but by doing predictions out of the data we have in the past. And one package we discovered for this is the package called Profit. Profit is from Facebook. So they're doing time series predictions with that. And it's really, really, really powerful. I only show you a short part of the functionality here. So what I do here is that I load the library, then I create my profit data frame where I use from the factory seller sales only the order date because it's time series and the value is sales amount. Then I rename the data in the data frame, the columns to DS. The order date is renamed to DS and the sales amount to Y. Why I'm doing this? Because the profit package expects the column names like that. And then I make sure that the date is really a date in the sense of R. So I'm not explaining this what I'm doing here, but more or less it's making the data available for the first of the month and being sure that's really the data type date. And then I sum up all the rows, so I only get one entry on the data frame per date per first of month. So that's what I'm doing here. So everything. So some of the data is not on the first of the month, but most of the data is there. So I just moving everything on month levels, and then I create a model by calling the profit function by passing in my profit data frame, the data frame we just prepared, and then I make a future prediction by calling the make future data frame, passing in the model, how many periods, so 6, I want to have a forecast or a prediction for the next 6 periods. What are the periods? M means month, so we are doing predictions for the next 6 months. Then so that's what the database makes up the data frame. Then I do the actual prediction. And then I merge the data with the forecast and the existing data frame. So I get all the data in one data frame so I can then plot it or show it. So if we show the last 7 rows, tail, you can remember the function I showed you already, the last 7 rows, we can see here that for the first row, we still have, where is it? So for the first row, so we do for the last 6, we have now a trend, a seasonal prediction. So this package is not only doing, it's showing what it's doing. So it discovers the trend over the years. It's showing seasonal things. Maybe bikes are selling better in summer, the warm season, than in the colder season. And we also have what is called where is it? So the daily thing, so that we find out then, of course, on Sundays we do not sell anything because then our shop is closed. And then we can, with the help of some of the visualization packages, we can then plot the data, for example, with the help of ggplot2. I can show you now the existing data and the forecast that should show up like here. So the blue dots are the actual values we have in our data frame. So that's the data out of the AdventureWorks. And as you can see, the red dots are not really there, but they're close to them. So the seasonality is discovered in the right way. And then from 2000, for the second half of 2008, we don't have any blue dots because it's the prediction. There 1, 2, 3, 4, 5, 6 predicted values from the package. And as you can tell you from the experience we have with live data, so we do, for example, monthly active users. We're predicting the monthly active users for Fantastic with the help of R, and it's really, really close to what's really happening. So if you see a trend going down, the predictions, it's really alerting us, and then we can do countermeasures to avoid this really happening. So that's a really short introduction into R. And why is R so useful? Because it's also integrated into the Microsoft Data Platform. Maybe it's not integrated in all of the tools. For example, in SSRS, in the reporting tool, we don't have a real integration, but we can call, we can use T-SQL to call a procedure which is executing the script. And I think I have a demo here available. So I can do the very same thing I've shown you in RStudio. I can do within Management Studio by calling the procedure exec sp execute external script, passing in R as a language parameter because my script is in R, with the version of SQL Server. This was introduced in SQL Server 2016. With SQL Server 2017, there's also Python available. And then I pass in a script. This is a really simple script. As you can see here, I just taking the input data set and assigning it to the output data set. And the input data set is, again, a script, and this script is in T-SQL. So I can use my data available on SQL Server, write my script, write a select statement, and pass the content or the result of the script into my R script, which is then called their input data set. And then I can use this. This is just a very simple example, so you can see how simple this is. And then I state what are the data types of the output. So what we are seeing here is that it's not really working because I'm in the wrong database. Sorry for that. And if I execute this, then we can see that the statement is disabled. Oh, how? My demo is not really working. Sorry for that. Let me fix this for you. I have to first, come on. Login, I think it should be here. No, it's not here, so it's not really working. So I'm sorry for that. I used a new computer. Yeah, already exists. This is okay, but I did not enable. We have something here. Yeah. I screwed up my demo here. Sorry for that, but the thing what you would be able to see here is that I can also pass in a more complicated script, like I showed you in the RStudio, and I can execute this and passing into the script again my data from my database. So that's the cool thing, is not to taking and exporting all data from SQL Server into a CSV file or making a direct access for the data scientists to the SQL Server, which means that all the data is transferred to the local laptop of the data scientist. It's a better way to transfer the script to SQL Server. So transfer R to where the data resides, and that's the idea of having this functionality like sp execute external script. So we can then do R and predictions on the SQL Server instead of moving all the data to a laptop and then uploading the prediction, but we can execute this. And that's what we're doing at Runtastic with as part of the data warehouse load, the daily load. So we do the predictions, and everybody who's be able to connect to the SQL Server can also then connect not only to the real data, but also to the predictions. And that's how you could include also predictions into reporting services. Integration services Again, no direct integration, but through the workaround, you can execute tasks on the SQL Server side and therefore executing R scripts. Then in Power BI, we have a really good integration, so we can use R scripts as a data source. We can use R scripts to transform the data. I'm not sure how often you will actually use this because connections to data sources in Power BI via Power Query are really, really good and easy. I would only use this when you already have an R script which you can use for this, but usually it's better way to use Power BI for that. And there's also a lot of nice visualizations available in Power BI, but there could be the use case that you have a certain visualization in mind which is currently not available via Power BI. Then you can do the visualization, for example, with ggplot2, which is a really, really powerful package, and then integrate this visualization into your dashboards and reports. And I think I'm running out of time because there should be time for Q&A at the end. And so I will skip also the demo for the R in Azure Machine Learning. You also create execute an R script. So if you lack some functionality out there in Azure Machine Learning, and you can also create your model with the help of R and then use this in Azure Machine Learning. That's also really a cool thing. So please check out the link provided here, studio.azureml.net. As this is a really cool tool, and when you do your machine learning thing there, you can just by clicking one button, it can be transformed to a web service, which you can then expose, for example, to users who are using Excel or to .NET application, which then can pass in parameters to your web service and then get back, for example, and again, the prediction. So you pass in the current values, sales amount and the date, and then it will return what is the prediction for the next 6 months, for example. That's things you can build with Azure Machine Learning. So I hope you get a good idea of why R is really a powerful and nice thing and why you should integrate into R Server. The integration of R into SQL Server helps us by not moving the data to R, but moving the R script to where the data already is. We also have resource governance. We also have security on SQL Server, because if you expose the data to a laptop, then it's in the file system there. And if anybody gets access to the laptop, then they also have the data. And I think it's more secure to have the data not on local machines, but on a server infrastructure. And you can operationalize your models, like I already told you, with the machine learning predictions, or you can integrate them into your SQL Server environment. There are some pitfalls I tried to show you. So there's case sensitivity. The dot has not a special meaning, and sometimes you have to use the double quotes, and sometimes you're not allowed to use them. So that's a thing. Yeah, you will learn when you work with R. So to wrap up, I did show you the introduction to R, and I showed you some of the possibilities how to integrate the data. And before I now open up for the Q&A, I think there are several slides from my host, Mano. Mano, back to you. Is anybody there?
Yes.
Okay.
Yes, sorry. I'm just trying to share my screen. All right. That was a wonderful session. So before we take further questions, I would request all the attendees to post your questions in the Q&A panel so that Markus can answer them.
Yes.
And while you post those questions, I'll just take you through a couple of slides before about the pre-conference day trainings that are happening at the Data Platform Summit. We have in total 12 pre-cons. The first one is on troubleshooting and optimize SQL Server like a pro by Dmitry Gotkovich. He's a Microsoft Certified Master from US. Again, if you're planning to migrate to Azure, there are new offerings like SQL managed instance, and there are a lot of changes to Azure SQL DB. So Sunil Agarwal will be doing a full day training on that. Power BI from Rookie to Rockstar by the BI expert from New Zealand. He's the Microsoft most valuable professional again. Dr. Leila Atati, who is the data scientist from New Zealand again. She's also an MVP. She's doing 2 pre-cons. The first one is on leading edge data science with Microsoft tools. Andy Leonard, who is a world-renowned SIS expert, is doing a day of intelligent data integration with SQL Server Integration Services and Azure Data Factory. Madan Gajendran and his team, the Cosmos DB team from Microsoft, is doing a full-day workshop on Cosmos DB full-day workshop on Cosmos DB. Sorry about that. Dr. Leila Atati, again, the second pre-con on building intelligence applications using the Microsoft AI platform. If you're really serious about learning R, the world-renowned expert on R, Steph Lockey, is doing a full-day pre-con on R for everyone. Sanjay Mishra, and his team, the Data Cat team, is doing a full-day pre-con on building scalable data architecture in Azure. Joy D. Anthony and Denny Sherry are coming back again this year. They have been continuous speakers since the conference started. So this year they are doing pre-cons, two pre-cons. Joey on Linux for SQL Server DBS. Peter Myers, who has been a very popular speaker last year, is coming back again to do a zero to analysis services full-day pre-con. As I've mentioned before, Denny Sherry is coming back and is doing a HADR pre-con. Please do visit dps10.com, which has more details. If you really want any help or information and you want any help convincing your company or your manager, please drop a mail to contact@dps10.com, or you can reach out on these numbers. The conference is again on from 9th to 11th of August, and the pre-conference day trainings are on 7th and 8th of August. It's happening in Hotel Radisson Blu in Bangalore, which is formerly Park Plaza. I'll hand over to Markus. It looks like his session was really, really explanative, so there are not many questions.
Either that or nobody, or everybody was confused and there were no questions.
No, it's mostly the first one.
Oh,
Yep,
no,
there's
there's a question. Is it mandatory for data scientists to learn Python? If I already know C# SQL Server and learn R, statistics, machine learning, do I have to learn Python? As I mentioned at the beginning of the talk, so I'm personally not a data scientist. I'm a data platform geek, I would say. And when I discuss with data science, there's like two worlds. Like one of the guys like Mercedes and the other ones like BMWs, and they can have big discussions about it. And that's the same for data scientists. So if you ask me, no, it's not necessary to have to learn Python. There are some use cases which are probably more easier to cover with R, and some others are more easier to cover with Python. So if you think about data visualization, that's much more easier in R. In Python, you have to. Python is a real programming language, so you have to write your code, your program, to do and to tell the computer what to do. In R, it's much more easier because you have all those functionalities and packages which you can use. So, do you have to learn Python? No, you don't. Start with R, and if you've got use cases which are hard to implement in R, maybe then go a step further and find out what Python has to offer. Any other questions?
All right. It looks like there are no more questions. So if you do have any questions, please do post it on our Facebook group, and we'll try to answer them. Thank you, Markus, for the wonderful session, taking out your time and doing this webinar today. And
thank you for
hope you enjoy your Easter break.
Yes, I will. Yeah.
Thank you, everyone, for taking out your time and attending the webinar today. It's been great to host this webinar. Thank you, everyone. Have a good day.
Thank you. Bye-bye.